You know how we always say there's more to things than meets the eye? Well, get ready because today we are diving deep into the world of alcohol.
Oh, yeah.
But not talking about like what's in your weekend cocktail or anything like that.
Right.
We're going full on chemistry mode today.
Yeah.
We're talking the what the how and the whoa of alcohols.
I like it.
And it's all thanks to this Wikipedia article excerpt that you sent over titled Alcohol Chemistry.
Yeah, you're in for a ride.
Okay, so let's break it down.
Okay.
The Wikipedia article throws out a very technical definition. First, an organic compound with at least one hydroxyl group.
Okay.
That's the AOH group, right?
That's right.
Bound to a saturated carbon atom.
It sounds a lot more complicated than it is.
It's a mouthful for sure.
Yeah.
It's a mouthful for sure.
But that little ACOH group that's like a VIP backstage pass in the world of chemistry,
Okay.
that is what makes an alcohol.
Okay.
And it gives it the ability to interact with other molecules in some very fascinating ways.
So you're saying that the ACOH group is the real deal?
It is the key player.
The Beyonce of the molecules.
Exactly.
Right.
And that single hydroxyl group,
Yeah.
it opens up a world of possibilities.
Okay.
So you have very simple alcohols like methanol,
Right.
which you'll find in things like antifreeze and ethanol, which is the one we're most familiar with in beverages.
Right.
But then you also have more complex alcohols like sugars,
What?
which is the stuff in your pantry,
Was
and even cholesterol,
No way.
which is vital for our cells.
Cholesterol is an alcohol.
Yes.
My mind is a little blown right now, I'm not going to lie.
Yeah.
Knowing what we do about these everyday things, but that
Yeah.
they have this like hidden chemical connection,
Right.
it makes you look at them totally differently.
It's amazing.
It's really, really cool. But I want to rewind for a second
Okay.
because before we get too far ahead, I'm very curious.
Yeah.
When did humans even realize that alcohols existed?
Right.
It's not like they were just like walking around with labels on them.
Well, you have to think back to ancient times. People were enjoying alcoholic beverages
Of course.
long before they understood the chemistry behind them.
Sure.
So we're talking philosophers like Aristotle, Pliny the Elder.
Okay.
They were observing the flammable nature of the vapors produced by wine,
Oh, wow.
noticing they could be burned.
So they knew there was something there,
Exactly.
but hadn't quite put their finger on it.
Exactly.
Okay.
It wasn't really until around the 9th century when things started heating up, literally,
Okay.
when Arabic alchemists made some groundbreaking discoveries.
Okay.
One such alchemist, Jabir ibn Nayyan, discovered that adding salt during the distillation of wine made those flammable vapors even more intense.
It's like they were literally distilling fire water.
That's right.
That's really cool.
And it didn't stop there.
Okay.
Scholars like Al-Kindi and Al-Farabi, they meticulously documented the distillation process.
Okay.
They created a foundation for others to build upon. And by the 12th century, European chemists were on the scene, producing their own version of this burning water,
Yeah.
which they called aqua ardens.
It must have been so cool to like witness that for the first time.
They must have been amazing.
That's so cool.
Yeah.
It's amazing how like those early discoveries just like paved the way for where we are today
It is.
with chemistry.
It's incredible.
But speaking of names, I have to ask,
Yeah.
where does the word alcohol even come from? Because
Yeah.
it seems so disconnected from everything that we've been talking about.
Get ready for a curveball,
Uh,
because it's pretty unexpected.
okay.
It actually comes from the Arabic word alcohol.
Okay.
Now, get this alcohol referred to a powder,
Okay.
antimony trisulfide used for eyeliner.
Wait, hold up.
Yeah.
Eyeliner.
Yep.
So we went from ancient eye makeup to what we now know as alcohol.
That's right.
That is wild. How on earth did that happen?
Language is a funny thing.
Yeah,
It's always evolving.
sure.
So over time, that meaning broadened. So first it referred to other finely divided substances than any distilled substance.
Okay.
And eventually it became more specifically linked to ethanol.
It's really interesting how like words can morph
That is
and like change over time.
right.
But I want to like zoom back to the chemistry for a second.
Okay.
Because we've been talking about alcohol kind of in this broad sense.
Right.
But I'm sure there's a more official way that chemists name
Oh, yeah.
and categorize all these different types.
It gets very specific.
So what's the inside scoop on that?
So in the official system used by chemists, the IUPAC system,
Okay.
which stands for the International Union of Pure and Applied Chemistry,
Okay.
we use the suffix "ol" to denote an alcohol.
Okay.
So you have ethanol, propanol,
Okay.
butanol, and so on.
Okay. So when I see that "ol" ending,
Yes,
it's like a secret code for, hey, I'm an alcohol.
that's right.
That's cool.
But it gets even more interesting.
Okay.
Depending on the structure or how that OH group is arranged within the molecule, alcohols are further classified as primary, secondary, or tertiary.
Okay, break that down for me. What's
Yeah.
the difference
Go on, Jim.
between a primary, secondary, and tertiary alcohol?
A carbon atom that is directly connected to that OH group.
Okay.
If that carbon is only attached to one other carbon atom,
Okay.
we're talking about a primary alcohol.
Okay.
If it's connected to two other carbon atoms, it's secondary.
Uh-huh.
And you guessed 3 other carbons means it's a tertiary alcohol.
Okay, got it.
Now, these differences in structure, even if they seem small, they have a big impact on how these alcohols react
Oh, wow.
and interact.
So it's like that old saying, like, it's all about who you know.
Right.
Or in this case, it's all about how you're connected.
Exactly.
Because I'm starting to see that with chemistry, it's all about the connections.
Yes.
And the relationships between these atoms and molecules.
You've hit the nail on the head.
Yeah.
It's a bit like a molecular dance floor.
I love that.
And depending on their dance moves,
Yeah.
these alcohols will pair up with different partners,
So,
leading to a whole array of possibilities.
and those different dance moves, those are what lead to like the different ways that they're used.
Exactly.
Right, because we've been talking a lot about ethanol,
Right.
you know, with the beverages and all.
Right.
But what about these other alcohols? Are they used for anything, or are they just kind of hanging out in a chemistry lab?
Oh, they are far from lab recluses.
Okay, good.
Alcohols are incredibly versatile,
Okay.
and they have a surprising range of industrial and commercial uses.
Okay.
You will find them lurking in places you'd never expect.
Really?
Take methanol, for example. You mentioned antifreeze earlier.
Right.
But it's also a key ingredient in the production of formaldehyde.
Formaldehyde, that's not something I want to be drinking.
Definitely not.
That's used in embalming, right?
That's right. It's a crucial component in preserving biological specimens.
Okay.
And it also has important industrial applications as well.
Got it.
And then there's 1-propanol
Okay.
and 1-butanol. You'll find these alcohols working hard as solvents.
Okay, like paint thinner and stuff like that.
Exactly.
Okay.
And acting as precursors to other important solvents.
That's wild to think that something that we often associate with drinks is also used to make these like everyday products.
I know, it's fascinating, isn't it?
It's really cool.
And it doesn't stop there.
Okay.
Those longer chain alcohols, like those with 6 to 18 carbon atoms,
Okay.
what we call fatty alcohols,
Okay.
they're the backbone of countless products, from plasticizers, which give plastics their flexibility,
Oh, wow.
to detergents.
Wait, detergent's like what I use to wash my clothes?
You got it.
You're telling me there's alcohol in my laundry detergent?
A specific type of alcohol, of course.
Oh my gosh, that's wild.
But chances are you are using it every single day without even realizing it.
This is really blowing my mind.
It's a perfect example of how diverse the world of alcohols truly is.
Yeah.
We encounter them in some form or another almost constantly, and yet most people are completely unaware of their presence.
This is so cool. Who knew there was so much more to alcohols than meets the eye, or I guess in this case, the glass?
Oh, no, right?
It's amazing.
It's truly
It's
fascinating.
really cool. Okay, I'm fully convinced now alcohols are way more versatile than I ever imagined.
They really are.
But I have to admit, learning about all these everyday uses, I'm kind of thinking twice about that, saying like a little hair of the dog.
Right?
Because we've talked a lot about like the really practical side of things, but what about like the dangers of alcohol?
Yeah,
Because we know that they can be toxic too, right?
absolutely. That's an important point, and one that we should definitely address.
Right.
While alcohols have this incredible utility, it is super important to remember that they can also have a darker side, especially when misused.
Right.
It's all about respect and understanding the potential risks involved.
Okay, so are there certain types of alcohols that are like particularly dangerous?
There are a few that stand out.
Okay.
Methanol, which we discussed earlier,
Yeah.
is highly toxic.
Okay.
Even small amounts can be extremely harmful.
Okay.
And then there's ethylene glycol,
Okay.
often found in antifreeze.
Right.
Both of these alcohols, when ingested, can really wreak havoc on the body,
Yeah.
leading to serious health complications.
Okay. Those definitely belong on the do not consume list.
Absolutely.
So what makes them so much more dangerous than, say, the ethanol that is found in alcoholic beverages?
It really comes down to how our bodies metabolize these different alcohols.
Okay.
So the enzymes in our liver,
Yeah.
the ones that are responsible for breaking down alcohol,
Right.
they treat methanol and ethylene glycol differently.
Okay.
And here's where it gets really interesting.
Okay.
The presence of ethanol can actually interfere with the breakdown of these more toxic alcohols.
What? Really?
making the situation even worse.
So you're saying if someone accidentally ingested methanol drinking, ethanol would actually make it worse?
It can actually exacerbate the toxic effects.
That is terrifying. I did not realize that.
Yeah, it's really important to remember that even though we use this word alcohol very broadly,
Right.
different alcohols have very, very different effects on the body.
Wow. Okay, knowledge is power in that sense, for sure.
Absolutely.
Okay, so we've talked about what alcohols are. We talked about their history, their sometimes kind of quirky names,
Right.
their diverse uses, good and not so good.
Yes.
But my inner chemist is now very curious. How are these multifaceted molecules actually made?
That's a great question.
Yeah.
And just like their applications,
Yeah.
the production of alcohols is surprisingly diverse.
Okay.
It's a fascinating blend of natural processes and then some really ingenious human inventions.
Okay.
For example, did you know that our own bodies are actually miniature alcohol factories?
What, are you serious?
Yes.
I'm making alcohols right now.
In a way, yes.
Right.
One method of alcohol production is called hydroxylation.
Okay.
It's a process where that OH group that we've been talking about
Right.
is introduced to a molecule,
Okay.
often using oxygen, or what we call an oxidant.
Okay.
And guess what? Our bodies use this very process to detoxify certain harmful substances
No way.
by making them more water-soluble and easier to eliminate.
That's incredible. Our bodies are way more sophisticated than I think I give them credit for.
They really are.
That is so cool.
Yeah.
But okay, so what about the alcohols that like we use for all those industrial and commercial applications?
Yeah.
Can't imagine my body is turning those out too.
So you're right. There are other methods for this kind of large-scale production.
Okay.
Two prominent industrial processes are the Ziegler and OXO processes.
Okay.
These ingenious methods start with what we call alkenes,
Okay.
which are hydrocarbons that contain a double bond.
Okay.
And through a series of reactions, they're transformed into alcohols.
So from double bonds to alcohols, that's quite the transformation.
It is.
That's cool.
And these processes are responsible for producing a wide range of alcohols,
Okay.
many of which we rely on every day.
Okay.
For instance, the Ziegler process is used to make cyclohexanol,
Okay.
which is a key component in the production of nylon,
Oh.
which I'm sure you encounter in some form or another on a daily basis.
Yeah, probably.
And remember those fatty alcohols that we talked about?
Yeah.
The ones that are found in detergents?
Right.
The OXO process
Mhm.
is a major player in their production.
Oh, wow. Okay, so it's like these industrial processes have like revolutionized the way that we live in a lot of ways.
Absolutely, they have.
That's really cool. But
Yes,
we've
we do.
also talked about fermentation,
Yes.
which is a much older process, right?
Yes, it is.
That's how we get like ethanol in
Yeah,
beverages.
You're exactly right.
Right.
Fermentation is humanity's oldest method of alcohol production,
Wow.
going back thousands of years.
Wow.
It harnesses the power of microorganisms,
Okay.
like yeast and bacteria,
Okay.
to convert sugars into alcohol.
Wow, that's so cool.
It's a beautiful example of how humans learned to leverage these natural processes
Right.
long before we even understood the chemistry behind them.
Totally. Yeah.
And it's not just for alcoholic beverages.
Okay.
Fermentation is also used to produce butanol, another important industrial alcohol.
That's really cool. It
Yeah.
seems like every time we delve deeper into like this world of alcohols, I'm just met with another like aha moment.
It's fascinating, isn't it?
It really is. But I have to admit, we've touched upon some kind of more technical terms,
Oh.
like you were talking about those reactions.
Yes.
What makes these alcohols so reactive in the first place?
That's a fantastic question.
Yeah.
And it takes us to the heart of what makes alcohol so fascinating.
Okay.
Their ability to participate in this wide variety of chemical reactions.
Okay.
So one of the key reasons behind this reactivity lies in a concept called deprotonation.
Deprocynation. Okay, that sounds a little intimidating.
It's actually more straightforward than it sounds.
Okay.
Remember that OH group,
Yeah.
the hallmark of alcohols?
Yes.
Well, under the right conditions, that hydrogen atom, the H in the OH group,
Okay.
can be persuaded to leave the molecule.
Okay.
We call this losing a proton because a hydrogen atom without its electron
Right.
is just a proton. And when an alcohol loses its proton, what's left behind is called an alkoxide.
So it's like the alcohol is shedding a layer, becoming something new.
Exactly.
Interesting. Okay, and what's so special about these alkoxides?
Think of them as the life of the party.
Okay.
Alkoxides are much stronger bases than alcohols.
Okay.
And that makes them highly reactive.
Got it.
They're eager to interact with other molecules,
Okay.
leading to a cascade of interesting transformations.
So what kind of transformations are we talking about?
So one such transformation is called nucleophilic substitution.
Okay.
It's a bit of a mouthful, I know, but Bear with me.
All right, nucleophilic substitution. I'm all ears.
So picture it this way. Alcohols, with a little help from our alkoxide friends,
Okay.
can actually swap out their OH group for something else.
Interesting.
It's like a molecular game of tag.
I kind of love that analogy.
So they might swap it with a halogen atom, like chlorine or bromine. It's like molecular Legos. You could use this reaction to build a whole range of new compounds with different properties and different functionalities.
So alcohols, the chameleons of chemistry, always changing things up?
Exactly.
I like it. I'm starting to see how they're so valuable as building blocks in so many different fields.
Exactly.
This is really cool. Are there other reactions too?
Oh, you bet. They have a whole bag of tricks.
Okay.
Another one of their signature moves is what we call dehydration,
Okay.
where they essentially lose a molecule of water, H2O,
Okay.
and transform into an alkene.
A minute. Didn't you say earlier that alcohols can be made by adding water to alkenes?
I did.
So it's like a reversible reaction.
I got it.
That's so crazy.
It's like a chemical dance with alcohols and alkenes gracefully moving back and forth.
I love it. Okay, so we've got dehydration. What else?
And speaking of dancing, let's not forget about protonolysis.
Protonolysis. Okay.
This reaction is specific to tertiary alcohols,
Okay.
those ones with the 3 carbon friends, attached to the carbon bearing that OH group.
Okay, the popular kids on the dance floor.
Exactly.
So what happens during protonolysis?
Well, in this reaction, those tertiary alcohols with a little coaxing
Okay.
can form something called carbocations.
Carbocations.
These carbocations are like the daredevils of the molecular world.
Okay.
Highly reactive
Yeah.
and ready to jump into new bonds.
Okay, so where do these daredevils come into play in the real world?
They're essential in a surprising number of processes, including the production of dyes. You know, those vibrant colors that we love in our clothes,
Right.
in paintings,
Yeah.
even food coloring.
Yeah.
Some of them owe their existence to these reactive carbocations.
No way. So we have alcohols to thank for those really beautiful colors.
In some cases, absolutely.
Wow, that's incredible.
Yeah.
Okay, so protonolysis. Where else?
And let's not forget about another fascinating reaction called esterification.
Esterification. Okay, that one sounds a little intimidating.
It's not as scary as it sounds. Esterification is like a matchmaker reaction.
Okay.
It brings together an alcohol and a carboxylic acid,
Okay.
which is another important organic compound.
Okay.
And when those two react, they form an ester.
Okay, esters. Tell me more. Why are esters so special?
Esters are responsible for some of the most pleasant scents and flavors
Really?
that we encounter in nature.
Okay.
Think about the sweet aroma of fruits like strawberries
Yeah.
and bananas,
Okay.
or the captivating fragrance of flowers like jasmine
Wow.
and roses.
You're kidding. All those smells are thanks to esters.
That's the magic of esters at work.
That's incredible.
It is amazing, isn't it?
That's really cool. Okay, so esters, anything else?
And we haven't even touched upon oxidation, another crucial reaction that alcohols undergo.
Okay, oxidation. I'm sensing a pattern here. Lots of reactions. Lots of possibilities.
Lots of possibilities.
But-
That's what makes it so interesting.
So what happens when alcohols get oxidized?
That's the beauty of it.
Okay.
The outcome depends on the type of alcohol and the reaction conditions.
Okay.
So primary alcohols,
Okay.
those with only one carbon neighbor,
Right.
can be oxidized to aldehydes,
Okay.
which are often responsible for those really pungent yet alluring scents
Okay.
that you'll find in cinnamon
Right.
and vanilla.
Oh, the warm, comforting smells.
Exactly.
Okay, but you said it depends on the type of alcohol, so what about like the secondary alcohols?
Excellent question. So secondary alcohols,
Yeah.
those with 2 carbon neighbors,
Uh-huh.
they get oxidized to ketones,
Okay.
which have a slightly different chemical personality.
Okay, interesting.
They're often found in solvents,
Okay.
but they also play a crucial role in the human body as hormones.
Oh, wow. Okay, ketones. I'm learning so much.
And then there are tertiary alcohols.
Right, those are the daredevils.
Remember those daredevils?
Yes.
Well, they're a bit more resistant to oxidation.
Okay.
It takes a little bit more effort to get them to react that way.
So it's like a whole family drama with each type of alcohol having its own like unique personality
They really do.
and own set of reactions.
Absolutely.
That's so wild. I never would have imagined that something as seemingly simple as like adding or removing an oxygen atom
I know.
could lead to such a diverse range of like products and properties.
It's incredible, isn't it?
It really is. It's like alcohols are the ultimate shapeshifters of like the chemistry world.
They really are.
Who knew that something that we often just associate with like a relaxing drink or something
Right.
could have such a wild and reactive side?
It's a testament to the elegance and the power of chemistry.
It really is.
These reactions, they might seem like these kind of abstract concepts,
Yeah.
but they really underpin so much of what we take for granted in our daily lives.
I'm seeing that now we started with what seemed like such a simple premise,
I know,
alcohol.
right?
And now I feel like I've stumbled into this like hidden universe within each molecule.
It is amazing, isn't it?
It really is. And you know what's really striking me is that we often hear about all of like the negative aspects of alcohol.
Yeah.
But doing this deep dive has really opened my eyes to its essential role in our world.
Yeah.
From like those everyday products that we rely on to those like really captivating scents and flavors that we cherish. Alcohols are truly like the unsung heroes of chemistry.
I couldn't agree more. They often get a bad rap. But the truth is, alcohols are fundamental to our understanding of chemistry.
Totally.
And they play a really crucial role in countless aspects of our lives.
This deep dive has been a wild ride.
Yes.
We journeyed from the ancient origins of alcohol
Right.
to its surprising presence in our everyday lives.
Absolutely.
We decoded its chemical secrets, uncovered its hidden talents, and even like faced its darker side.
That's right.
And it's all thanks to that Wikipedia article on alcohol chemistry that you sent over.
Yeah, it was a great place to start.
It's amazing how much information is packed into those digital pages.
It's a treasure trove of knowledge, for sure.
It really is. And you know what? It just highlights like the beauty of science,
Yes,
that there's always more to learn, more to discover,
absolutely.
and more to question.
Always more to question.
Well, on that note, to our amazing listeners, if this deep dive has sparked your curiosity, we highly encourage you to check out that full Wikipedia article.
Yeah?
Consider it like your launch pad for further exploration into the captivating world of alcohols.
Absolutely.
Who knows what amazing insights you might uncover.
Exactly.
And that's a wrap on our deep dive into the incredible world of alcohols.
Well, it was fun.
Until next time, keep those minds curious and never stop exploring.